Hi, I'm Eric Ragan from the University of Florida. I'm presenting work done with two undergraduate students from Texas A&M University. I'm talking today about transitions between viewpoint changes in VR. So we have a lot of different ways, a lot of different options of moving around in virtual reality. But there's so many advantages where it's very, very common to see simple teleportation from doing a change from one place or one orientation to another. And this might be because you're trying to look through large environments or do a case where the environment might not allow you to physically move around. And it's a nice, very simple way of getting a viewpoint change. But there's a lot of options where it's not just teleportation. There's a transition between moving from one place to another where there's different visual differences that you can impose to make that change. And depending on the different type of transition that you use, this could have implications for your ability to make sense of what is going on spatially in the scene during the viewpoint change, and of course sickness, in terms of how does this view manipulation affect people's comfort and general state of being. In addition, a lot of times when we're thinking about travel techniques and virtual reality, we think about users are controlling where they want to go. You know, I'm in control. I have freedom to move around, to look around, and change where I'm looking, when I'm looking. But this isn't the only case that we want to change our viewpoint. In fact, there's a lot of different applications where we don't have full control over the experience. Now, for example, there's many guided types of experiences, like in virtual tourism, or architectural walkthroughs where maybe there's a prescribed path through the environment, or in collaborative scenarios where perhaps there's one driver, one person who's in charge of leading the experience and controlling and dictating what the motions are going to be. Another example is immersive video and immersive movies, where sometimes a director might have some types of cuts to change locations or to change a perspective to try to encourage viewers to view what the director thinks is most interesting to what they think they should be looking at. And so the research overview for the studies that I'm going to be presenting here are these cases where you have transitions where the user is not in control of initiating a viewpoint change. And in particular, we're interested in spatially tracking what is happening in a dynamic environment when things are moving. So to get right into the details of this study, we have environments where objects are moving around. So here you can see the objects indicated here in blue. And they are moving, as indicated by they are moving. And in this study, we would have a viewpoint change where the position of the person would shift to a different place. And at the same time, halfway through this transition, one of these moving objects would disappear. It would then be up to the participant to try to do a pointing task and point to where they think that object was when it disappeared, which allows us to calculate the error in their tracking of the spatial objects. So we did a series of studies across two different test environments with some images of those test environments here, where these moving objects were done by these fairly simple virtual barrels that you see with these identified by these arrows, and we had these barrels moving around. We also wanted to study different types of viewpoint changes, and we did this with considering translation, rotational changes, as well as compound both translational and rotational movements. And this work consisted of 4 experiments where we did a whole set of different types of transitions. And this was all done with an Oculus Rift with positional and rotational tracking. But I will point out here that although people could freely rotate and turn and move around, and they can use the positional tracking, there was very little positional movement. It was mostly just people were fairly still, looking around from left to right, up and down, but not so much actual translational movement. To try to give a broad overview, I don't want to go into too much detail of all these different studies because doing 4 studies in a short amount of time is a little bit intense. We'll try to do a broad overview of some different types of transitions included. Also, for example, an instant viewpoint change, which you could probably imagine, boom, it just pops to a new location, versus a fade, some type of fade transition where it's more of a gradual shift in between. Sometimes we might also consider doing an animation where we have an interpolation, a smooth interpolation between two viewpoints. I will mention here that we did different speeds for the different animations. And something that is a little bit off with these videos is, remember, people did have the ability to have head tracking, so people could normally look around while this is happening too. Something else that we considered was somewhat of a middle ground. Partway in between the teleportation option where you instantly move to a new location and have this animation version, we call this a pulsed type of transition, where we have intermediate jump points in between your start point and your final destination. And we tested here different numbers of intermediate points from the start to the beginning. So you'd be able to see smaller sets of transitions rather than just a single transition to the end. So this work was conducted over a series of 4 experiments, with each experiment for the first 3 was looking at different variations of these individual transition types. And then the 4th experiment was trying to take one from the first 3 experiments and putting those together. Each study was done with 18 unique participants, and each study was done with a repeated measures fashion. So there's of all the work that I'm going to be talking about today, there were 72 participants total, but each experiment was done with 18 participants. We're primarily interested in this spatial awareness of their ability to monitor what was happening as these objects moved around and disappeared partway through the transition. But of course, we were interested in sickness and comfort. Were people getting bothered by these different types of view manipulations that we were enforcing on them? For sickness, we did use the SSQ from Kennedy, but I will say that it's really hard for repeated measures designs to do multiple similar sickness questionnaires because sickness is compounding over time. And so we also had people do a subjective rating where after they were done with everything, they compared the different types of techniques directly. So to jump right into what happened. First thing we'll notice is that looking at these teleportation results with this fade to black versus an instant no fade, there really wasn't any kind of difference in terms of people's abilities to monitor spatial changes. We do notice that rotations were a little bit easier to keep track of what was happening, how things changed. So anytime that we were having some kind of transitional change, that was going to be harder than just doing a rotational change. For the experiment where we looked at different animation speeds, overall we find, okay, animations, the amount of error was a little bit lower. But in this case, there wasn't any significant difference. There was no real difference between these translational, rotational, or combined viewpoint changes. And the speeds were all pretty good. Looking at the different types of pulse, this was the intermediate jumps between viewpoint changes. Again, our spatial error shows we have rotational changes were significantly easier to monitor the tracking the dynamic objects than to have anything that has the translational motion in there. But in terms of the different types of the number of intermediate steps, didn't really make a difference. So that's a quick overview of those first 3 studies. And after we did those first studies, we did an additional experiment where we wanted to take one representative transition from each of those first studies and compare them to each other. We could have just directly compared the results from those previous studies, but what we really, really wanted is to make sure that we had the same participants trying all of these so that we can get subjective preferences and comparisons between that. So we wouldn't have been able to do that because we had unique participants in the individual experiences. So in the combined study, here's what we found. Overall, we could find, as expected, having the animation, having those transitions, yes, they definitely helped with having significantly lower error. People were able to more accurately keep track of where those objects had been when they disappeared as they were moving around. Interestingly enough, in terms of the types of viewpoint changes, we see some interesting things where this effect of rotation being easier, that was not significant all across the board. We did find in this combined study that whenever we had both translation and rotation together, that was overall significant effect, where those both combined transition types, those viewpoint changes were significantly harder for people. It looks like here where there might have been an interaction effect, but it didn't come out as statistically significant. So the other thing that we looked at, in addition to the spatial orientation, is, of course, the comfort and sickness. The hard part with this is everybody has their own opinions. There's not just a right choice across the board. But what we see here is results for people's subjective ratings of sickness. Now, and this came from a relative comparison. So people were directly asked to compare and rate not just a numerical rating individually, but rate them relative to each other. And here we see higher means more sickness. The animation has a lot more sickness. So even though that the animation was helping people keep track of what was going on better, this caused sickness results. So a lot of people in this community might say, this is probably obvious. And that's one of the reasons why I wanted to do this, because I thought this was fairly obvious. And yet, as VR is becoming more commonly used, I'm finding more people that don't think this is obvious and that keep wanting to use more animation for different things. So this is one reason why I was motivated to do this type of work and have something where I could say, look, if you're worried about animation, depending on your experience and your use case, if you're worried about sickness, depending on your use case, maybe animation might not be the best choice, even though it does have advantages for keeping track of spatial awareness. We also looked at overall preference, and this came from a set of 3 questions doing the similar type of direct comparison. And everybody has very, very wide differences, where there wasn't a clear winner by any stretch of the imagination. If you look at these black median lines in the middle, the solid bands in the middle of these box and whisker plots show the median. They're all fairly close, and these are very, very wide spreads. So it's really hard to just say we have a winner for many of this. So we can't say we know exactly what the right case is, but we do see pretty compelling evidence that we have to consider trade-offs in terms of comfort and sickness and in people's ability to maintain the sense of what is going on in terms of changes in space. There are things that we could consider in terms of alternatives to this pulse technique as a middle ground. That's clearly not the only thing we could do. And there are lots of other types of options for transitions that might be worth exploring. So this could lead to really great opportunities for future research to see if there might be potentially really nice transitions that allow you to preserve the benefits of maintaining spatial changes that you get from animated techniques without having the sickness effects. So good options for future studies. Other things that are worth thinking about are super fast animations. Some applications and development toolkits have very, very quick animations that are just a couple frames fast. So we might consider that in future work as well. And the other thing is looking at the amount of head motion, head control during the transitions. So that's a summary of my work. Thank you very much.
Nice work. I had a question about the range of people you saw that liked animation, or the feelings they had, where it seemed to be a wider range than from some of the other transitions. And did you look at the correlations between people who liked the animation transition and whether those people might have had less sickness than the people who didn't like it?
I will say that overall, the sickness results, even though people had pretty strong preferences in their ratings, the overall sickness perceived was relatively low. I know that doesn't come across in the subjective ratings, but that's because it's a direct comparison. What I didn't talk about, or what I didn't present here in the slides, was the SSQ results, which were all fairly middling. So for this reason, I don't think that it would have been the strongest reason, it would have been a clear indicator that would cause it made me real sick. I would.
Although often SSQ, especially with things that are not really done in simulators and are moving around, don't tend to really do a good job of indicating how people feel.
I agree. Yeah.
And in between your sessions, how much time was there between the sessions?
Oh, that's a really good question, and honestly, I don't know off the top of my head. We did enforce breaks. I believe the breaks were between 3 and 5 minutes.
Oh, that's really
dur-
short.
During each session. So the experiments were completely separate with completely separate people.
Right, sure.
Right, but each individual experiment had blocks where they would go through a few
Right.
trials that would take a few minutes, and then they would take a 3 to 5 minute break,
Right.
and then they would.
Because if someone who actually gets sick, it can often take hours.
Right.
And sometimes even well over a day.
But people, even though they're rating things in terms of sickness, no one really got sick here. It was the sickness scores were very low. So the sensitivity of these subjective ratings were people just saying, well, how does it make you feel,
Right.
more than saying I was getting very, very sick.
And how much time did they spend in each condition?
So each experiment was a little bit different in terms of the total number of conditions, so it varied a bit, but generally between 30, 45 minutes.
Of being exposed to
Oh, each trial? Okay, we could talk more, but short.
Okay, quick question. Going to ask for a little bit of speculation on your part, but do you think in a room scale VR setup where they're using a hybrid of natural walking for local movements and then teleportation for larger scale movements, do you think that you would see similar magnitude of effects? I'm specifically thinking of the large difference in the amount on the pointing error that animation helps.
So what's the difference are you asking about between the room
Well,
scale
I was just wondering if they were using natural walking in conjunction with with teleportation in a room scale setup, if maybe they would be able to compensate, and maybe animation wouldn't be such a big a benefit over the others on the pointing error. But I was just asking for
So
your
if you're
opinion.
using physical navigation, then maybe you would reduce the amount
Yeah.
that you would need to automatically transition. Yeah, it seems like it could potentially work, or because if you're combining physical and virtual quickly, maybe that could confuse. So I don't want to speculate too much, but I think that because you would reduce the amount of change, that would make it easier to follow the change.
Thanks.
Yeah.
Thanks. Thank you.
Thank you.